I've been doing in Yellowstone the last few years. I'm going to do a little bit beyond my tenure. I've been working in Yellowstone since 2009, studying mainly gray wolves, and I switched over to cougars in 2014. So I'm going to be focusing primarily on those two species, but I'm going to touch a little bit on some of the other populations in the park. Also, in my past, I've studied black bears and grizzly bears, and pumas in Colorado, Utah, Alaska, throughout the West, in a variety of different ecosystems. And so let's dive right in. The overview of what we're going to be talking about tonight. I'm going to first start off with just telling you guys why we study carnivores. Some of the conservation issues that we are currently facing in the world, as well as in Yellowstone and parts of the West. And then we'll bring it into a little bit more of a place-based location with an orient to you guys to the greater Yellowstone. I know some of you guys have already been to Yellowstone, but some of you have not. And then we'll go into my primary study species, the cougar. We'll talk about cougar ecology in Yellowstone, starting off with the history of carnivore management in the park, some of the population monitoring that we're doing, which is a main part of my PhD, how we use remote cameras to monitor behavior, habitat selection, as well as radio collaring. We'll end with the different types of collars that we put out and why we put out those radio collars. And so why we study carnivores is mainly due to this. We have a large-scale decline in carnivore species throughout the world. This particular graph right here, the scale from gray to red is talking about the number of carnivores that are declining in a particular area. So if there's a red area, that means that there's more carnivore populations that are declining. And these are the four main processes that are leading to carnivore population declines in most areas. We have habitat loss and fragmentation, which can occur in logging or residential development. Persecution, which tends to be through more of a concerted effort to decrease carnivore populations for certain reasons within the particular area. Utilization for traditional medicine, fur. In North America, we're talking mostly about trophy hunting when we're talking about large carnivores. And then depletion of prey, too. Depletion of prey populations can lead to a decline in carnivore populations. And a lot of the depletion of prey populations feed back into these other three processes as well. And so why this is so concerning is because of the role that carnivores play in ecosystems. They can shape ecosystems through direct and indirect processes. In this particular slide here, I'm showing you guys a typical ecosystem like Yellowstone with gray wolves or a carnivore at the top. You could replace them with cougars in this case too, where they're having a direct effect on certain species, like the coyote, where they're killing coyotes, decreasing the number of coyotes in the system, which allows pronghorn to increase or small mammals to increase. Or respectively, if they were to prey on elk and decrease the number of elk on the landscape, that would lead to increases in woody plant growth, which can change stream morphology or increase beaver habitat, increase bird habitat. Or through these carcasses that are on the landscape, elk carcasses, they can provide carrion subsidies to other species like grizzly bears, black bears, or other scavengers like birds, even all the way down to soil microbes. And so this is what we see playing out in Yellowstone every single day. With the greater Yellowstone ecosystem is a 20 million acre area. It's a mosaic of private and federal and state lands with Yellowstone National Park at its core. Yellowstone's about 2.2 million acres, and it comprises a lot of the core habitat for many wildlife populations. And we focus most of our research on the northern part of the park. We call it the Yellowstone Northern Range, and you'll see this in a lot of different papers and books. And a lot of the research on carnivores and ungulate population dynamics, disease dynamics, it all focuses on this one area of the park. And as you can see, it goes over the park boundary. And so we're dealing with Forest Service land, private land, state land, and national park land. It's important to recognize as an ecologist that animals don't see boundaries. They cross these boundaries that we've placed on the landscape. They're political boundaries. They mean absolutely nothing to ecology. And so it's important to know that critical habitat can occur on any type of land. And it's also important to note with this particular area too, we have one road coming through this which is another reason why we've chosen this area to study more in depth, because of it's accessible year-round. It's the only road in Yellowstone National Park that's open all year long. And it's also delineated mainly by the elk habitat. That entire shape that we saw there in purple on the last map is the winter range for Yellowstone elk. And for the Yellowstone Northern Range elk, it's a one herd. It's the largest herd that uses Yellowstone. And they've numbered as many as 22,000 in the past. Right now they're closer to about 6,000 to 7,000. And they also coexist with 5 other large ungulate species. The bison. Yellowstone has one of the largest free-roaming bison herds and still left. Mule deer, moose, bighorn sheep, and pronghorn antelope, the fastest land mammal in North America. And because of this really rich diversity of ungulates, as well as a high density of ungulates, it can support a lot of carnivores on the landscape. And so we have all of the extant native carnivores that were in the system 10,000 years ago. Starting with the gray wolves, seen here feeding on a bison carcass. Coyote, black bear, grizzly bear, and cougars. And interestingly, when we're talking about carnivore management, the history of carnivore management in Yellowstone, it varies dramatically depending on the species that you're talking about. For cougars, it was much like this. This was a common theme that you would see in the late 1800s, early 1900s. There was a very large-scale eradication program implemented by the federal government to eradicate all carnivores. And they were able to do this throughout much of the range. For wolves and cougars, they were both eradicated from Yellowstone by about the mid-1920s. For black bears and grizzly bears, it was a totally different story. They persisted throughout this entire time, mainly due to the tourism attraction that they served. Up here you can see black bears being fed on a roadside. And this was a common scene all the way back through the early 1900s, through the mid-1900s, with black bears and grizzly bears being fed on the roadside as well as being fed at garbage dumps. They actually had garbage dumps set up throughout the park with stadium seating. And you could watch upwards of 30 to 40 grizzly bears feeding on all this garbage at one time. And so carnivore management, specifically for cougars and wolves, has shifted recently, more towards a trophy hunting management plan. Seen over here on the right side, where hunters can pay large amounts of money to go out and hunt a cougar. This money then gets fed back into the management system and used to conserve certain areas or to pay for managed hunting in others. Now, cougars are extremely adaptable species. They're found in almost every single habitat in North and South America. They have the largest distribution of any land mammal in the Western Hemisphere, all the way from the southern part of the Yukon, all the way down through the southern tip of South America. They have a huge distribution, and because of it, they've come into contact with cultures for millennia. They actually have the Guinness Book of World Records for the most common names, over 42 common names, which is unbelievable. So when somebody's talking about a mountain lion, a puma, a catamount, it's all the same species. And so Yellowstone, particularly, has had a really rich history in cougar management and research. Now, I told you guys before that they were eradicated in the mid-1920s. Now, they reestablished their own population in the mid-1980s. So they came back on their own, mainly because of the huge wilderness areas that surrounded the Yellowstone area. And as soon as the cougars were seen to be coming back into the area, they decided to instigate the first research program, which took place in 1987 and went through 1993, with the goals of documenting not only how many cougars there were on the landscape, but how they were distributed spatially on the landscape. And the area was characterized mainly by no wolves on the landscape and a very high elk density. Now, wolves were reintroduced in 1995 and 1996 to the area, 31 wolves in total over the 2 first years. And the second cougar project, now we have wolves present. It took place from 1998 to 2006, with similar goals of trying to figure out how many animals there were on the landscape, with the understanding that now the dynamics of the system have changed. Wolves are now back on the landscape, and they can alter ecosystems pretty dramatically. And so they knew that there was going to be competitive effects trickling over to cougar populations as well. And so they estimated 13 to 18 cougars to be on the landscape. There's now wolves present. There's still a very high elk density. Now in the first cougar study, there was about 20,000 elk on the landscape. During the second cougar study, it was declining at that point. I'll show you guys a population map soon. And so there was a gap of about 8 years of no cougar research. And so we reopened cougar research in 2014 with the idea of trying to figure out how many cougars there were now on the landscape. We have a lot fewer wolves on the northern range. During the second study, there was as many as 74 wolves on the northern range, which is about 1,000 square kilometers. There's only about 35 now, so pretty dramatic shift in wolf populations. We also have a lot fewer elk on the landscape too. And so now we want to try to see how these things can correlate with each other over time. And importantly, during the second phase of cougar research, there was a 2-year study that occurred that was instrumental in me choosing to do the work that I do. Their goal was to evaluate some of the non-invasive genetic sampling tools for monitoring a cougar population. Non-invasive genetic sampling refers to trying to get genetic samples on the landscape without ever touching the animal. And so they tried 2 different methodology during this study. They used a scratch hair pad, which is this picture on the left side, which is actually a carpet remnant with screws drilled in it and tacked up to a tree. In this particular picture, they actually have catnip in that little to try to lure cats into it. Surprisingly, male cologne also works really well for luring cougars into it. But unfortunately, that methodology did not work for this particular case. What they did find is that snow tracking, so these are a picture of cougar tracks over there on the right side, snow tracking was actually a very viable tool for being able to identify individuals. Snow tracking occurs when you actually walk a transect, you try to find cougar tracks, you stay with the cougar tracks as long as you can, and try to find scat or hair or blood that the animal left behind. Send it off to the lab, and they try to identify genetically the individual. And then we do a bunch of fancy statistics and try to spit out a population estimate for it. And so this was the methodology that I chose to try to use in this current study. And so our study area is about a 650 square kilometer area on the northern range. This gray area is the park boundary. So Gardner, Montana is this little guy right here, for those of you that have been to the northern part of the park. And all of these red lines are DNA survey routes that we walk. We try to walk every single route weekly. We have about 22 sampling routes that we walk currently. So this would be equivalent to about this area for this particular site here. So about 650 square kilometers with about Ben Lomond at the center point. And this area is characterized by prime cougar habitat, extremely steep terrain, rocky, with dense forest cover. This is a picture of the Black Canyon of the Yellowstone. Much of our study area straddles the Yellowstone River Canyon as it moves through out of the park. And a lot of the fieldwork is characterized by extremely harsh conditions. We're there doing our sampling from about mid-December through March. Temperatures can be as low as -40. And we go out every single day regardless of what the conditions are. There's some funny stories about these pictures if anybody wants to know them afterwards. And so our sampling protocol tends to look like this. We're walking those red, heads up, walking those red transects, and we try to find cougar tracks, a track line similar to those up in the upper right-hand corner of this slide. And we try to stay with those cougar tracks as long as we can until we find a genetic sample. A scat sample like in the lower right-hand corner, or a bed site. In that middle picture on the bottom is a typical bed site that you'd find for cougars. They try to look for a little cave area that's secluded, protected from weather. Or we can find even a spot where a cougar sat down. This lower left-hand corner is where an animal sat down. You can see the back feet right here, the front feet there, and a tail swale coming off to the right side. And so when the animals sit down, they tend to drop a lot more hair. And what you really want for a genetic sample for hair is you want the root follicle. That's where all the genetic material is. And so you want the hair to be pulled out from the root follicle at best. And so once we find a hair sample, we get down on our hands and knees, and we try to find every single hair that we can in the bed, sometimes with a magnifying glass. Or with a scat sample, we're taking location information with a GPS unit. We're trying to record all the information about the track line that we can with the iPads. So we want to know the sex of the individual, the age of the individual. You can tell all of these from the stride length or the width of the rear pad. We also want to look at quality indicators for the DNA samples. As DNA sits out in the landscape in nature for extended periods, the genetic material starts to degrade. And so UV radiation and moisture contact can kill your DNA sample. And so we want to know how fresh we think the sample is so that when we get the information back from the laboratory, we can then kind of cross-validate things. And so we've had a pretty successful last 4 seasons where we've traveled over 635 survey routes, we've walked 5,500 miles, collected 830 genetic samples. And interestingly, a lot of cougar habitat is, since it's so steep, the mileage doesn't necessarily mean that much. Over these 5,500 miles that we've traveled, we've traversed over 1 million feet of elevation gain and 1 million feet of elevation decline. And what this amounts to is a bit over 6 miles per genetic sample. So it takes a lot of effort in order to get these genetic samples. And the reason that we travel so much is because there is a low genetic success. So since these samples are out on the landscape for extended periods, we actually have really low success as far as amplification to individual genotype. In the first year of the study, we only had 23% of our samples actually give us individual identifications. In the second year, only 32%. So we still are waiting on 2016 and 2017 to come back from the lab. But during the first 2 years of the study, we were able to identify 20 individuals on the landscape, 7 males and 13 females. And we were also able to see where they're located spatially in the study area. And as you guys can see, we've got a pretty high concentration in that Yellowstone River corridor. And the big reason for this is because that's where all the ungulates are. That's where all the elk are. It has lower elevation than the bottom of the river canyon. And so because of the lower elevation, the elk travel down because it's easier to get to the forage. They don't have to fight their way through deep snow at the higher elevations. And so with the ungulates traveling down to these lower elevations, the cougars and the wolves are also going to be following them down there. And so with this information, we've been able to come up with a population estimate for the first 2 years of the study. And this fits into larger goals for the National Park Service and Yellowstone National Park of monitoring multiple populations over time. This blue line on this graph shows you the elk population going back all the way to the 1920s. And you can see there's some pretty big dips, and then there's a big rise, and then we're back down into a decline right now. And so you can imagine that if we were only to study elk in this period right here, it wouldn't be quite as interesting as if we were to study them over time. And so that's why we're coming back to the cougar population right now to look at population and try to see what's now going on. That little tiny red dot is those first 2 years of the study that we've got. And after we come up with the 4 years of the study, the population estimates, we'll be able to backfill that area back to 2006 when they were done with their previous study. Now it's also important that we try to graph all these other species on the landscape. A lot of talk when it comes to Yellowstone is you talk about wolves and you talk about elk. But it's not that simple. We start to look at grizzly bear and cougar populations and we can start to see a correlation between all of these. And particularly when we're talking about recruitment. And recruitment refers to how many new individuals they bring into a population. And so elk calves are a really important food source during June when they're starting to be born. And so grizzly bears, wolves, and cougars all prey on this prey source during that time of year. And so grizzly bears actually end up being the biggest taker of elk calves during that time of year, followed by wolves, then coyotes, then cougars. So it's important to look at how all these populations are coming together to interact and compete for resources. Now that wraps up some of the population monitoring that we've been doing, and I want to tell you a little bit more about some of the remote camera work that we do. Well, I'll show you guys a remote camera later. It's over there and the mic doesn't go that far. So while we're walking these DNA survey routes, we also have remote cameras in our backpack, and so we can set them up opportunistically when we find something. Thank you. So just to show you kind of the size of a remote camera, it's really small, and within this it takes HD video and takes 8 megapixel photos, and you can leave it in the landscape for months. And so you can leave and come back in a month and then take the card out and see what you got. So it's a really cool tool that's now available to wildlife biologists. And what's really cool about remote cameras too is that you have a study species that you're trying to get photos or videos of, but you end up getting all of these other species in your photos. For cougars, we're looking at about a 2% success rate for photo and video. So the other 98% is all the other species in the park and some grass and trees, usually too, moving in the wind. But in this particular case, this is a camera set on a migration route. So we can actually monitor the elk migration as they're coming through and moving through in the fall and then again in the spring. And we also, it's kind of hard to see, but down here is a red fox in the lower right-hand panel. And so a typical DNA survey route with remote cameras would look like this when we come home at the end of the day, where the GPS is tracking our movement on the blue line, and then all of a sudden we come into a bunch of cougar sign where all those flags are. We might have found some tracks, then we followed them, and then found some DNA samples, and then we may have found a scrape site. And these scrape sites are really important for monitoring a cougar population with remote cameras because you get a lot of action at them. It's how cougars interact and communicate with each other. This is an adult male coming into the scrape site, sniffing around, and trying to see if there's any cougars there previously. And he has found a little spot where an animal has scraped. You're going to see some scraping behavior in a second, where this animal is going to push up some duff with its back feet and then urinate on the duff so that the duff will hold its scent for a longer amount of time. Now, males are coming to these scrape sites to communicate to females that they're available to mate. They're also coming into scrape sites to tell other males that it's their territory and to see if there's any females to mate with or if there's any other males that they need to be wary of that they're going to be competing with. So these scrape sites are really important to try to get cameras up on. And they can be really important to our population monitoring too. Oh, he got us. And then we can start to look at change over time. So we see this adult male, he came and then he left. And now we see an adult female come in with 2 kittens. And she's going to smell in generally the same area. You can see the camera angle is a little different. It's the same spot. And so the female is coming in for somewhat similar reasons. She's coming in to see what other cats are in the area. But she's mainly coming in to see if there's any females that she might be competing with. But she also wants to know what males are in the area since she has kittens. Infanticide is one of the largest causes of death for young animals in a natural population free of human disturbance. And so in order to keep her kittens safe, she needs to understand where the males are and how they're moving. Now she's also teaching her kittens how to behave at a scrape site. You can see right there she's sniffing the air, trying to pick up any olfactory cues. And then the kitten does it right after her. And this is another scrape site. The scrape is right here. And it's really hard to see, but the camera is right up there on the tree. So we had this particular camera up in 2014, and we ended up getting all of these species coming by and hanging out at our scrape site. The top panel has a pack of wolves moving by, with the last animal coming into the scrape site and doing some sniffing. The middle panel has a grizzly bear that's decided to bed down in front of the camera. He ended up bedding down for about 36 hours in front of this camera. There were about 225 videos that I sat through watching this grizzly bear. In the bottom panel, it was quick, but a female came through, urinated, and then left. So sometimes females don't even stay that long at a scrape site. If they don't pick that much olfactory cue, they just kind of come and go. They might urinate and then keep going. And there he goes. So this was about mid-March of 2014, so he probably just came out of hibernation. He's really sleepy. And then this wolf was really interested in the scrape site, but weary of the camera. We got some really good videos of this grizzly bear. I gotta show you a couple. There's 225. We had a couple gems in there. Doing some yoga moves. Just sleeping away. Now what's also really cool about this video series too is we got to see how he reacted to humans. So he's sleeping, all of a sudden he gets up, and his eyes are the biggest they've been for the previous 224 videos. And the reason why is because the DNA survey crew is walking up the drainage right now yelling, "Hey bear." And so he gets up and moves away. So it was really cool to see how a grizzly bear might react to our noises before we even get there, because we would never see this. Now, we have video of the DNA survey crew coming up to this bear bed, seeing that it's fresh, touching it, seeing that it's warm, and then they start really yelling, "Hey bear." It's pretty funny. Now, we also set up these cameras at kill sites. This little cluster of points right there was a mule deer fawn. Now, it was completely untouched when we came up to it. This was the first day after a really bad cold snap in 2014. There was 3 days straight of -35 to -45 temperatures, and this animal was not able to survive through that. So we set up the camera to see what animals would come in, and we saw some really interesting cycles, pretty similar to other carcass sites that we also monitor, where we have avian species coming in during the daytime in the upper left-hand corner. You're going to see something really cool come in on that upper left-hand corner. You don't want to miss that. And so there's a social hierarchy within the avian species too that you're going to see play out. And then at nighttime we have all of our mammalian species come in with a cougar in the upper right-hand corner. So that was a golden eagle coming in and pushing the bald eagle off of it. And then we have a red fox in that middle panel on the right side, and then a pine marten, which we don't see very often at carcasses, but we tend to see them more at cougar carcasses than wolf carcasses because their habitat types tend to overlap a bit more. But what's so cool about this is you have a bald eagle feeding up there. A golden eagle comes in, boots it off, and as soon as they're gone, now the other smaller avian species come in. You have magpies and ravens come in then. So these remote cameras are a really great way to monitor behavior between species, as well as within species. We can look at how family groups interact at carcass sites. This is a female that had 3 yearlings. You can see a collar on a male on the right side. The adult female is facing away from us. And the 2 other kittens are squabbling over the carcass. You can see she was hissing at the cat over to the left side of the carcass. And you're going to see her hiss at her again. As well as mom not liking the way her son is acting at the carcass. So it's really cool to get to know these individual animals. They all have different personalities and they all act differently at carcasses or at these scrape sites. But none of this would have been able to be documented without a radio collar. So while I love non-invasive genetic sampling or using a remote cameras non-invasively, they don't answer all the important questions to conservation. And in some cases we need these radio collars to be able to tell us a little bit more about animal movement, behavior. And so we've been trying to place these GPS collars on individual cougars over the last 4 years. This was the first male cougar that we were able to capture in 2015. This is M198. Unfortunately, he died about 25 days after we put the collar on. He was killed by another male in the northern part of the study area, but we would have never known about this had the radio collar not been on the animal. And so it's important to be able to document how animals die on a regular basis. And it's even more important in Yellowstone too to be able to understand how these animals behave, how they die in the absence of humans. Humans are pervasive predators on the landscape and they dominate most landscapes at this point. Yellowstone is one of the last refuges in North America, the lower 48, that's free of human. And so to catch cougars, we use trained hounds. And we do a similar methodology to our DNA survey routes, where we walk a drainage where we think we're most likely to run into a cougar. Once we find tracks, we want them to be within about 12 or 13 hours old. And then we let these hounds go on these tracks. And the hounds are able to use scent cues from the track, as well as a visual cue of the track line to be able to follow these tracks as long as possible. And they're sprinting. And as soon as they are able to catch up to the animal, the cougar is going to climb a tree. At that point, the hounds are going to wait at the bottom of the tree for us to show up. And we have a little GPS device that tells us exactly where all the hounds are at any given point. It updates about every 5 seconds. The unfortunate part about it is that how fast the hounds and cats are. For about every 15 minutes that we don't see the hounds that are ahead of us, we're about an hour behind them. So at any given time, we might be 45 minutes to an hour behind the hounds, and we're going to be trudging through snow for about 3 to 4 hours to try to get to them at this tree. And we try to get there as fast as possible so that we're not sitting with the cat up in the tree too long and stressing it out. And once we get to the tree, we dart the animal with a disassociative anesthetic, and we climb up into the tree, put climbing gear around the animal, and then lower the animal down to the other biologists waiting. At which point we start to take samples like blood for DNA, hair also. We put on a radio collar. We also take morphometrics data, so looking at how long the tail is, how big the paws are, how much they weigh. In case if we ever recapture this animal, we can look at change over time, and we can also compare this animal to other animals that we capture, depending on age and sex class. And we also want to put an eye mask on, and we never want to be touching the animal unless we absolutely have to. So as you can see over in the right-hand panel, we've got an eye mask on to reduce any of the sensory overload for the animal, as well as we don't touch them so that we're not stressing them out. Well, we can do some really cool things with these radio collars. One of the primary goals of these radio collars is looking at predator-prey dynamics. And we use something called GPS cluster analysis. This map right here shows you a typical GPS points for a cougar. These happen to be 30-minute locations. So if we look over on the left side of the panel, we've got a 30-minute location. This animal is traveling. We can see they travel, then they travel all the way over to here. And then they come into here, and all of a sudden we've got a cluster of GPS points, and even a second cluster right nearby. And so once we identify all of these clusters from these GPS collars, we hike into every single cluster and try to see if the animal made a kill. Most of the time, they were just bedded down for an extended period, but sometimes they make a kill, at which point we want to know what they killed, so the species of concern, as well as what age and sex class of the kill that they made. In Yellowstone, we're looking at about a 70 to 80% of the time it ends up being elk, with about 10 to 15% being deer, followed by bighorn sheep and pronghorn, and then small prey like porcupine and marmots. So a porcupine carcass up here in the upper left-hand corner. This is a deer mandible here, and you can age the animal by looking at the teeth wear on the back piece right there, on the premolars. And then we also, I guess I'll back up a little bit. When we first show up to the carcass, we actually want to try to figure out who killed the animal. So down here we start to look for signs of what we think might have killed the animal. For cougars, we can see right here they actually have puncture wounds on the neck. The carcass is slightly disarticulated, so it's kind of moved around a little bit, as well as it being cached, and this is one of the primary things that you're looking for. So a cougar is actually, once they take down the animal, once they're done feeding the first time, they're going to take a bunch of duff and hair and snow, and they're going to pile it up onto the carcass. And this does a couple things. It keeps the meat from spoiling in summer or freezing in winter. And it also makes it harder for scavengers to be able to find it. It doesn't smell as much. As well as when the scavengers do find the carcass, it's much harder to dart in and get to the meat if it's covered in dirt and debris. And we can also look at some other cool things like predispersal behavior. These next few slides, I'm going to tell you a little bit of a story that we were able to come out with one of the radio collared females that we found. This is actually the family group that I showed you the video of a couple slides ago feeding at the carcass. This was F202 and M201. Those numbers don't mean anything to you guys, but it might help to keep some things straight. In this particular case, we were able to identify a GPS cluster right here. We hiked in and were able to find the animals feeding on the carcass from afar. So we were over here looking across the river. This is M201, the son, and one of the other yearlings just above the carcass. But F202 had already left, the mom. And she had traveled over into this area right here. And we picked her up at a remote camera that we had set right there. There she is right there with the radio collar. And so she had actually met up with a male. You're going to see him walk across the panel again in a second. And this was during the prime part of breeding season. And so this big old male was at this other camera that was just around the corner from that other video camera that we just saw. We were able to see that this was a really large male, an older male too, since he's covered in all these scars and notches in his ears. This shows that he's been in a lot of fights with other males for territory or for mates. And he actually has an active cut right there on his lip too. And we can use some of these scars to identify individuals as well over time if we start to get more videos of the same individual. Now after they were caught on that camera, which was right here, they traveled all the way over to here and made an elk kill there, which actually happened to be wearing a collar as well. Which was also extremely important information for the elk project, to know how elk were dying on a regular basis. Now just following all of this that just happened, we were able to monitor how M201, the son, dispersed. Now cougars tend to stay with their mom for 14 to 18 months on average, but they can stay with mom for up to 24 months, almost 2 years. And we were able to watch this animal's dispersal behavior. So up here was his natal range where he was born. He traveled north of the park, went over the park boundary, and then traveled almost the entire eastern boundary of the park. Came down over here, hit some human settlements right here, which then made him bounce north into this Forest Service land in here. So again, reiterating, these animals do not see political boundaries that we've placed on the landscape. Now, unfortunately, this animal was harvested on the first day of hunting season, just right outside the park over here in Sunlight Basin. So also important data for understanding how these animals move over these political boundaries, and then what happens to them once they move over political boundaries. Now, what was also really interesting with monitoring the breeding behavior of F202 and the unknown male is we were able to monitor what was going to happen in the next 3 months. The gestation period for cougars is about 92 days. And so we were able to see that she had 4 kittens in mid-June. Now we wanted to know how many kittens she had for some of our other questions that we're answering. These collars over here actually have accelerometers in them. And I can just pass these around. But I'm going to pass you guys 2 collars. The small one is from F202, this cat that you just saw. This collar was on the animal for about 13 months. This other collar is brand new, hasn't been used, doesn't have a battery on it. But look at the different sizes. One's for a male and one's for a female. So you can see the sexual dimorphism of 2 cats. And so within these collars, coupled with the GPS, which takes locations anywhere from 30 minutes to 1 hour to 3 hours, depending on the time of year, it also sends that information directly to our computers at given intervals, so we can monitor it almost in real time. But they also have triaxial accelerometers on board, which are similar to what's in your smartphones, actually. Most of you have smartphones that have a health app that measures your movement over time. It tells you how many steps you take. These actually have the same sort of technology in there, but they're measuring movement on 3 axes. So X, Y, and then Z as well. And with that information, we can look at a couple different things. We can look at the behavior of the animal. So on these movement signatures, they tie up to whether the animal is walking, running, feeding, or sleeping. We can also look at energetics. So we can look at how many calories an animal is burning, as well as coupled with how many kills we find of there. So we can look at the calories coming in and then the calories going out, and seeing if animals are living with a deficit during certain times of the year and what that might be from. So it's important to know how many kittens a female has to understand the energetic demands of reproduction. And we have these same exact collars on wolves as well. And so we're monitoring the energetic and ecophysiology of these two top predators in the same system. In this panel right here, we have the yellow dots are actually all wolf GPS locations. All the pink dots are from one cougar. So we can see that their habitat selection matches up pretty finely. And so these animals are likely coming into contact on a regular basis. They're competing directly for prey. I told you before that cougars prey about 70 to 80% of the time on elk. Well, wolves are about 90 to 95% on elk. So both of these animals are primarily using the same exact resource. And so understanding how habitat selection might be feeding into predator-prey dynamics is also important. So in summary, we spoke a little bit about some of the non-invasive genetic samplings and how it's a viable tool for monitoring cougar populations over time, and how this might fit into a multi-species population dynamic model, especially in Yellowstone, where we're trying to understand how all these different species interact and compete for the same resources. Remote cameras give us a very unique glimpse into animal behavior in carrion subsidies and scavenger use of different carcasses, as well as how our radio collaring can help us understand predispersal dynamics of cougars, predator-prey interactions, and multi-carnivore habitat selection. And importantly, how all of these methods combined can help you answer important pressing conservation questions. So any one of these methods might not have gotten us to being able to tell that unique story of F202, but coupled together, we were able to find some cool things out. And finally, cougars are very adaptable, behaviorally complex animals that we don't normally see. And so all of these methodologies give us an opportunity to be able to look into the daily lives of an animal that's rarely seen. So I'll end it with showing you this series of photos that was actually taken by a backpacker on the Lamar River corridor. He happened to be hiking the trail, and this animal started to cross the river, trying not to get wet, hopping from rock to rock. Unfortunately, it was caught in the river. And so I want to acknowledge some of the key players in this project. Not only the principal investigators, Dr. Dan Staler, Tony Ruth, Mike Sawaya, and Howard Quigley, as well as some of the key donors that help us do all the work that we do. During the first year of our project, the National Park Service was very generous with giving us some important startup funds. Ever since then, we've been relying on private donors and nonprofits to make sure that we get this important work done. If you guys are interested in getting updates, we do some updates in winter and summer on an Instagram feed. My boss told me to put a plug in there for that. And I also want to thank the many, many technicians that have helped make this project work. There's no way that we can walk 5,500 miles by ourselves. We owe it to all these guys that work day in, day out in really harsh conditions to get this job done. And I'll go ahead and open it up to some questions.
You showed us some declines earlier when you were looking at so what do you attribute that to?
I assume, I'll repeat that. She was alluding to the declines in the population graph that I showed earlier, and I assume you're alluding to the elk lines?
But also was the wolf went down.
Yeah, so I'll start with the elk. The elk decline that we saw that was going all the way down until about the mid-1960s, then we saw a huge raise. So the decline that was happening during the 1960s was actually from humans. So there was culling, poaching, and park managers were actually culling about 2,000 to 4,000 animals per year, as well as allowing a late hunt in the spring for extra cows outside of the park. Once that stopped in the late 1960s, their population rose with pretty much no predator pressure from top-down forces. Moving on to wolves. Now, wolves had
The more recent
recent decline. We're still trying to figure that out, actually. A lot of it probably has to do with increasing carnivore populations. We have the greatest carnivore diversity and abundance right now than we've had in 150 years in Yellowstone. But there's also other things like climate, human use outside of the park. A lot of habitat fragmentation and development is occurring outside the park. A lot of development within the greater Yellowstone has happened in the last 20 years for private land. For the wolf population, we had a couple of major declines in the 2000s. Both of them were mainly due to disease. There was an outbreak of canine parvovirus and canine distemper, which tends to hit most of the younger pups. They cannot survive through those. And we think that the more recent decline that we've seen, so they've gone from about 100 animals in the early to mid 2000s, and now they're down, 170 animals in the mid to early 2000s, all the way down to about 100 animals now. And that's mainly due to, we think that they're finding some sort of carrying capacity with the elk on the landscape. We think that what we're seeing right now is probably the normal wolf density that we would expect. It's a good question. Yes?
Are there penalties for killing a collared animal?
No, there is no penalty for killing a collared animal. So an important aspect of that is also we want to know how collared animals die. So if collared animals are not allowed to be hunted, then it wouldn't tell us very much about human carnivore interactions outside of the park, because then they're actually being saved. Yes?
You talked about an animal that you showed a slide where the animal was born and then it went down to human population and went up again. And you said harvest. It was taken the first day of harvest. Is it just hunting what you're talking about harvesting?
Yes, that's trophy hunting for cougars. In Wyoming, Idaho, Montana, many U.S. states, cougar hunting is a primary objective of management outside of national parks and U.S. wildlife land.
It's interesting that it used harvesting.
That is the terminology that is used for it, whether it's political or I don't know why. But that's the terminology that's used. Yes?
Your Instagram site.
Yes. Instagram is cougar _ oh no, sorry. Yellowstone _ cougar _ project.
And are there other places where we can keep track of the
We'll probably have some annual reports coming out, and if you go to the National Park Service, the Yellowstone National Park website, you can find a lot of these annual reports that are periodically updated. Yeah, in the back.
Cougars and wolves ever interact?
I'm sorry, what was that?
Do cougars and wolves ever interact?
Yes, definitely. The second phase of cougar work was primarily looking at how cougars and wolves interact, and a lot of this happens at kill sites. So an elk really draws in a lot of animals, scavengers, other large carnivores, and so a lot of these animals interact at carcass sites. In the early days of when wolves were reintroduced to the area, some areas were documented where almost 80% of the carcasses were visited by wolves. So a cougar killed an elk, and 80% of the time wolves came in and kicked them off of the carcass. They also, when they come into contact, can kill each other. So cougars have been killed by wolves, and wolves have been killed by cougars. Yes?
In the video of the scrape site, did they find the scrape site by recognizing what it looks like? How do you recognize what a scrape site looks like?
How do researchers identify it, or cougars?
How do researchers know what a scrape site looks like? Would we be able to recognize a scrape site?
Yeah, you can definitely recognize a scrape site. A lot of it helps with following tracks into it, so having snow is very helpful. The other thing, though, is they tend to be located under protected areas, so under a large tree where they're not going to be hit by rain or snow that's going to deflate the scent, as well as it's not going to be hit by wind a lot that'll destroy the little scoop that they make. And what you're looking for is basically the width of 2 cougar paws scooped up into a little tiny little pile. And so you'll see a little run out section of where the paws were, and then a little scooped out area. And then if you're really dedicated, you can get down and smell the pile to see if it smells like cougar urine. Yes.
Your radio collar seems really heavy. Is it possible to have a microchip instead?
That technology has not come out yet. So there's some species that they have ear tags that are pretty small that'll transmit just a VHF signal. So you can pick it up with specialized radio telemetry equipment. But in that small of a package, you cannot fit a GPS location with battery life that would warrant capturing an animal. It's very expensive and time intensive to capture animals. And one of the big things with that collar, if you feel the male and female collar, most of the weight is in the battery. So collars are getting lighter and lighter every single year as our battery technology gets better.
Thanks to Elon Musk.
Yeah, there you go.
Yes. Show it.
So, can you remind me first, like, what your population estimate was for 2013 or?
Yeah, for 2014 and 2015, we estimated between 18 and 20 individuals,
Okay.
which was, oh, sorry, go ahead.
I was just gonna say, so like, when they first started monitoring them, they were at around 11,
Mm-hmm.
and they like climbed up to 13. Now you're at like 18, 20.
Yeah.
That seems so low to me still, and I'm wondering like what your guys' impression of that is. Are you like, oh no,
Yeah.
you really gotta save the cougars, or are you kind of like, this will recover over time?
So, interestingly, it's about an average cougar density. So when we're talking about cougars, we're usually talking about the number of cougars per 100 square kilometers. And so that is actually a pretty average cougar density. They occur at really low densities, which is what makes them so hard to study. But we're not worried about it. And one of the interesting things too that I didn't say about that graph is, a lot of that population increase that we saw is monitoring cougars as they were coming back. So that population increase might just be them coming back to the landscape and building recruitment year after year, absent of any other processes going on. So it's kind of internal. Yeah.
So you said that trophy hunting was a way that they were killed. From what I've read, a lot of carnivores are killed because of conflicts with livestock.
Mm-hmm.
And actually free-range livestock, which people have preferred because they think it's more humane, actually means a lot of carnivores are killed. So I wondered if you could talk about habitat loss from all the farmland we use to grow food for livestock, and then guardian dogs and ways to prevent having to kill predators, and how maybe if, considering we're in this mass extinction and carnivores are really being dying right now for many reasons, maybe eating less meat would be a way to prevent them.
Yeah, so the question, I don't know if you heard it back there, was a question about how cougars might come into contact with livestock and how animals are killed on a regular basis due to these negative interactions. A lot of sheep farming tends to be done on Forest Service land. That's where a lot of grazing allotments are done. And it tends to be done in prime carnivore habitat. That's the way it's been done for a long time. And it's a way of life in the greater Yellowstone ecosystem. A lot of people depend on their livestock. Dogs have been used to guard livestock, and they have been proven to be a viable option for guarding certain types of livestock. A lot of it, too, happens to be when an animal dies, taking the dead animal out of there before carnivores come in, too. I don't know if I'm getting to all your questions. There's a lot in there.
Yeah, I mean, I have goats, and I live in Puma country.
Right.
I rescued 2 dogs from the shelter, 2 big dogs, and I've never lost them
Yeah.
in over 10 years.
I mean, a lot of it around here, I'm not a huge expert on this, but a lot of it around here is bringing your animals in at night. Can do a lot. Bringing them into an enclosed area with high fences or into an entirely enclosed like barn. And that pretty much takes care of most puma livestock interactions.
Pumas can jump like 12 feet, right?
Yes.
Yeah. 12 feet, yeah.
But Anna might have some more information on that.
Yeah, we recommend a covered shed.
There you go, covered shed.
Fencing, we normally like Or like in a covered shed with a locked door. So yeah.
So she said a covered shed is the best way to do it, for those who didn't hear that over there. And, you know, for the most part in Yellowstone, we don't deal with that because there's no livestock in the park. When animals leave the park, they do come into contact with livestock. So we had 2 wolves disperse in similar areas as this cougar, and both were shot from depredation with interacting with livestock. So it happens, and it can account for a lot of mortality in these animals.
Yeah, I know in our area I have predators coming by during the day too. Yeah, so the dogs are really important. Yeah, for me, I know.
Nice. Yes?
2 questions, and I don't know if you can answer either or both.
I can try.
One was about, I had heard that, I forget exactly which park it was, but they were talking about how reintroducing wolves at a ridge